Okay, so just, can you see that? Yeah. So I'm using .NET Interactive Notebooks just before you spend the whole talk thinking about how I'm doing this. If you want to know how that went, it's on Twitter. It's not perfect, but it'll do for today. So I've got 15 minutes. I will stick to that, I promise. Okay, so I'm not going to overrun. So I want to talk a little bit about encryption in C#. And just as background, I'm Frans. I'm CTO of NewOrbit. We help companies make the most of Azure. That's sort of what we do. So because of that, can you read that? Yeah. I get the pleasure of going into companies and looking at how they do things in Azure, including their security. And when I get to do code reviews, and very often when they try and do encryption in C#, they do it wrong. And it's because, as Jamie was saying earlier, the encryption APIs in C# are not designed with compassion at all. They look like they're designed to cause you pain and get you to do it wrong. So it's not your fault when you're getting it wrong, but you will almost certainly get it wrong if you just try and use them, sadly. One thing I will say is, if you are doing state secrets or protecting millions of pounds, don't listen to me. I'm just some random bloke in Oxford on a Tuesday night. You go and get a cryptographer, okay? This is not good enough for those scenarios. And a cryptographer will tell you what I'm telling you is not good enough. It's good enough for standard stuff. This is how Microsoft do it for most of their stuff, but not for state secrets, not for millions of pounds, okay? Not my fault if you get broken into. It's the user's fault. That was the message, right? Okay, so interestingly enough, I think the most likes I've ever got on a tweet was about 10 likes. I posted this question about whether somebody would like this talk, and I got 201 likes and counting. So clearly there's a need for this talk. So I'm going to give you 5 things that I found. The first one that I actually find people struggle a bit with is it's bytes all the way. People start doing encryption and they say, oh, I need an encryption key, and I think of an encryption key as a text string, it's a password, right? It's not, it's a byte array, and that already throws people straight away. But it's because encryption is math. It doesn't understand things like text and real world things or files. It just works on long strings of bits that it breaks into blocks, and then they do math functions on them. Okay, so just understand that it's all byte arrays. So before you even try and do encryption, make sure you understand streams, byte arrays, text conversions, and stream writers. And it's worth spending a couple of hours learning that first if you're not 100% confident before you even look at the crypto APIs, because otherwise you're just going to cry with frustration because nothing makes sense. I promise you. And you'll see in my code examples, there's 15 lines of that and 1 line of encryption. Okay. So I will talk a little bit about text and bytes and streams for the purpose of this talk, but I can't cover the whole thing. So the first thing, you may already know this, but if you have text in C#, you actually have to convert it to bytes before you can encrypt it. So if you want to encrypt text you have in memory, you need to convert it to bytes first. And typically, there's a few ways you can do that. You can do ASCII, UTF-8, UTF-16, and this is the thing about if this works. Yay, look at that. So you'll see that they have different benefits, right? So ASCII is not good because you don't get the right results back, whereas UTF-8 is usually good. UTF-16 or Unicode is what C# uses internally, but it's a lot more memory hungry. So rule number 1, if in doubt, just use UTF-8 everywhere for this kind of stuff, unless you have a really good reason to do anything else. UTF-8 is a really good default. Second thing is, so we have streams and we have byte arrays. And for our purposes, they're sort of the same, okay? They hold a string, a sequence of bytes. And the difference is more about that with byte arrays, you have to pre-declare them. They have to be a specific length. Streams, you can generally just keep writing to, so that makes them a lot easier to use. Except sometimes for some streams, you can't go back. You can only write and read forward, depending on the stream type. And by and large, generally recognized, streams in C# are a mess. It's a way overextended API that covers way too many abstractions. So again, here's pain, because history. But that's sort of generally when we talk about streams and byte arrays, it's that kind of thing. Now, so back to the bytes. So the reason I'm sort of talking about it, this is what it looks like if you do the standard cryptography APIs sort of without the syntactic sugar. Now, it looks fairly decent, but you can see our key is a byte array, our input is a byte array. We are having to do a lot of byte array math here to do working out the lengths of the output arrays. We have to do stuff like this where we're looping over things, calculating positions and offsets and that kind of stuff. That's if you use the sort of the under the hood APIs, which is why I don't recommend you use those unless you want to spend several hours figuring it out. Instead, use the stream APIs. They are, I want to say they're less ugly. I'm not sure they are, but at least you're not having all of that weird math. What you trade it for is all of these things that wrap each other. Stream writers that wraps a crypto stream, that wraps a memory stream, and stuff like that. But it does make sense if you do what I said first and actually go and have a look at what these things mean. And just spend 2 hours figuring that out. Once you do that, this is actually really easy to understand, and it makes an awful lot of sense. And it's really relatively easy to use. Okay. I am slightly behind. Okay, good. The first thing I would say is, and this is a question that often comes up, is, so hang on, we got asymmetric encryption and symmetric encryption. What do I use? The answer is really simple. You use symmetric encryption. Symmetric encryption means you use the same key to encrypt and decrypt. So you have some kind of secret, you encrypt with that, and then you get the same secret to decrypt the data. That's really fast. It can handle vast volumes of data, but asymmetric encryption can be more secure. But asymmetric encryption, that's the public-private key pair, so you use one key for encryption and another one for decryption. It's really slow, it's bloated, the output is massively bigger than the input, and in practice you can only really encrypt about 160 bytes with it. So you can't really use it in practice for anything real world. Okay, but you can combine them, and I'll explain briefly how to do that at the end. So you get the best of both worlds. The second point is people sort of say, okay, symmetric, that's great. You then go and look up symmetric encryption in C# and you find you got half a dozen different options. So the first thing is you use AES. That's the one you use, okay? There are other things. If you're doing, again, state secrets and stuff, you probably want to use AES CDM or various other things or even some other ones. But if you're just doing everyday standard, you're going to encrypt some secrets in your code, use AES. Again, it's what Microsoft use for things like Azure Blob Storage. It's pretty decent. Also, people say, oh yes, but AES uses Rindale underneath the covers, so I'm going to use Rindale. And if you go and look at the Microsoft documentation, they sometimes use Rindale as well. Don't do that. It's obsolete. If you actually, so don't do that. That's bad. Do that. That's good. Okay? Keep it simple. Use AES. Now, that was number 2. Number 4, leave the default settings alone. Okay? Again, the C# APIs really are like, they're like you have all of the sharp knives there that you can go and mess with, and you can make secure encryption really insecure by changing a default. If Coding Horror from Stack Overflow has a nice blog post about how he did that in the early days of Stack Overflow. So again, bad code, good code. Okay? Just don't mess with it and don't spend time trying to figure out what they do. You need to be a cryptographer, genuinely speaking, to understand what any of that does. And I'm seriously, so just don't mess with it. All right. Finally, this is important, and I've seen really bad, dangerous internet examples. The IV value is important. So what that is something called an initialization vector. It's like a password, a random salt for a password hash, or a seed for your random function. It basically is a random sequence of 16 bytes that gets that kickstarts the encryption function. So if you take the same value and encrypt with the same encryption key but 2 different IVs, you end up with a different encrypted result. And that's extremely important, because if you get the same result from the same input text and you store that, that's a very, very wide open attack vector for people to try and figure out what your data is doing. But I have seen examples on the internet where they say, oh yeah, you just set the IV value to 0 so you don't have to worry about it. That's bad. So what you do is you always have to, so every time you create AES, it's really helpful because it creates a random IV for you. And again, it's random in the cryptographic random sense, not random as in mastered random, which is you should never use for anything security related. And the thing you then do is the convention, and the easy way to do it is that if I could, it won't move. Sorry, I'm just gonna have to do it this way. If you, oh, there we go. Here, if you look at this, you take that IV and you just write it to the beginning of your output. You basically say whatever you're outputting to, the first 16 bytes is the IV, because then when you read it back and you want to decrypt it, you just take those first 16 bytes and that's your IV, because it doesn't have to be kept secret. It's just a seed, okay? So don't keep that. It is really important to make what you're doing secure. And those are my 5 things. So I've got a couple of examples and a little tiny bit of bonus content. I'm 3 minutes behind. I'm sorry, guys. So I'm going to do this quick. I'm just going to run a couple of. I'm just going to create a file we can encrypt, and just a little utility function. And then, this is another thing, creating an encryption key. See, people often do they make up some phrase like my super secret password, and because they want to store the encryption key in config. I recommend you do this instead. What that does is it tells AES to create your a cryptographically random key as a byte array, and then base 64 encodes it. So it's not a string, it can never be, well, it's a string you can store because you store the base 64 representation. That's a much better way of doing it rather than making up fancy words, because you get the entire pool of available bytes for your key. Okay, so this is a proper example of how to do it. So what this is doing is taking a file, reading it, encrypting it, and then it's going to decrypt it in a minute. The key to that is when you're using streams, and especially with a standard AES, it's really nice because you can tie streams together like what we're doing here. Most of this is really just about all of that conversion between bytes and setting things up. The entire encryption happens in this line here. Okay? That's how easy that is. So what that can also be is your input stream. In this case, it's a file. It could be in a request stream on a website, and the output stream could be an Azure blob storage or another file, or it can be whatever you want it to be. So that's the nice thing about the stream interface, especially with large data in this scenario, because you don't even need to have all the data in memory. You can stream it through if you're encrypting large sets of data. Albeit there are reasons you shouldn't do that, which I'll come on to. But you know. And that's basically it. And then a decrypt looks like this. It's a little bit more complex because we're opening up our encrypted file, and we're creating a new file to output it to, and then we need to, as I said before, the first thing we do is we read the IV. We just read the first 16 bytes, that's our IV. And then we put that into the algorithm, and then we do the decryption. And if I run this code, you'll see that the input works and the decrypted works. And if I very quickly show you the actual encrypted file here, looks like that. So, you know, it does work. Alrighty. Does that make sense so far? Alrighty. Now, this is text encryption. It's essentially the same, so I won't go into all the details. Just to point out, this is where we have to do things like using a stream writer in order to convert from the in-memory text to the binary representation. You will notice before I didn't do that even though it was text files, and that's because once stuff is in a file, it is already bytes. It has already been converted. So I sometimes see people, oh, it's a text file, so I'm going to read it as text and then convert it back to bytes in order to encrypt it. So don't do that. If it's in a file, it's bytes already. If it's in a stream of any kind, it's already bytes. Don't mess around with converting it to and from text. The only time you want to do the text conversion is when you're dealing with in-memory strings that are already in memory, or you need to put them into memory. Okay, otherwise, don't do it. That works too, by the way. So a GitHub Copilot is really cool. It even works inside the notebook, except it did put some bugs in there because it wrapped the wrong streams, and it took me like an hour to figure it out. And anyway, it's my fault for relying on the tools. See the user fault. Okay, I have a bit of bonus content for you, and then I'll wrap up. The first one is there's something called the envelope method. So one problem with what we have said is that we're using the same symmetric key for everything we're doing. And that means if somebody gets that symmetric key, it's really, really bad news, right? Because they can now decrypt all of your content. So the best scenario you can do is that you have a unique key for every single item. So every single time you want to decrypt a text string or file, you create a new unique key just for that one thing. And that AES will actually do that for you automatically. When you create a new AES, you get a unique key and a unique IV automatically. And then, of course, you have to do something with that. So basically, the way the envelope pattern works is that you take this symmetric key, or the content encryption key they call it, and you then use a public-private key pair asymmetric encryption to encrypt your content encryption key, and then you store the encrypted key with the content. Does that make sense? There's a lot of levels going on there. That is how Azure Blob Storage client-side encryption works, and you can literally go and see it in the metadata. They put in the encrypted encryption key is in the metadata for a client-side encrypted blob. So again, if it's good enough for Microsoft, it's good enough for me. You can generally do that with Azure Key Vault. It's an easy way to do it. You can hook it all up, so that will do that for you. And then you can have key rotation on your public-private keys as well. So you get, like, even if somebody breaks one of your public-private keys, they only get access to a small subset of your symmetric keys and a very small subset of your content. The other thing, and this is one thing I did not know for a long time. So this is the same code we had before, except I'm going to start modifying the encrypted data there in the middle. So if I'm a malicious attacker, imagine we have stored this data somewhere, and I'm an attacker, and I've gone in and I've actually just modified bits of the content, or bytes of the content, I should say, on disk or whatever. What do you think happens when I start decrypting that content? See, I always assumed it would throw an exception and say bad stuff. So let's try and run the code and see what actually happens. So it turns out it is perfectly happy to decrypt it and give you back nonsense. There's no integrity validation whatsoever on this data, and it turns out that this actually can be exploited in real-world scenarios to do bad things. It doesn't just give you bad stuff. It can actually be exploited to break security. So there's something called Authenticated Encryption, which I just want to introduce you to. The general idea is that you do your encryption, then you do a hash of it, and then you do an HMAC, basically a message authentication code, and there's a few different ways you can do that. You can either, there's a book I'm referencing, securitydriven.net, that explains how to do it with another encryption key, or you can use Azure Key Vault. That is one of the nice things they can do with public-private key pairs. You can send it a hash and it will sign it, and then you can attach that hash to your encrypted content, and then people can't do this thing. Now, the advice is, if you're using AES in the mode I have described here, you should always do authenticated encryption. Most people don't. I think as a cryptographer, you should say that you do it. In practice, I think in a lot of scenarios, personally, I don't think, I think people genuinely don't do it. Whether they should or shouldn't depends on your risk profile. Again, if it's state secret, yeah, you definitely need to do it. If you're just storing somebody's NI number, not so sure. But, it's just something to think about. Two very shameless plugs. I know I'm over time. I'm really sorry. I'm working on an open source library that encapsulates all of this stuff. I've been actually working on it for 3 years, but I haven't done it. But this talk spurred me on to get it done, and I'll have it done in the next week or so. It wraps Azure Key Vault and AES, and then does authenticated encryption and all of that stuff. So, but with a nicer API, because I think the C# API is horrible. So have a look back in a week, and hopefully I've done something nice. Secondly, as I mentioned before, my business, we are an Azure reseller. We help developers make the most of Azure. So if you use Azure, or if you know somebody who uses Azure and don't want to just buy Azure from one of those warehouses of software, but want to buy Azure from somebody who actually understands that language and can actually help them, especially around security and cost, just point them in our direction, and we'll talk to them and see if we can help. And references, just these ones. This is all over GitHub. That's a notebook, and GitHub renders notebooks really nicely, so you can read it.